Good evening, everyone. Welcome to OTF Connects and our session tonight on coding and exploring patterns in movement through coding. Exciting stuff. This is such a popular topic these days, and I'm really happy to be meeting Lisa Floyd for the first time tonight. She has done sessions for OTF Connects and others, but I'm really happy to be welcoming her tonight. She brings a wealth of experience to this and has lots of great stuff to share with us. Lisa's in London. She is with the Thames Valley Board, I believe. I'm not sure if she's currently teaching. We're going to ask her that question, or she'll share that with us. And I know that she's also working with Fair Chance Learning, and I'm excited to hear a little bit more about that. Lisa, you know Brian Aspinall, don't you?
Yes, yep, we work with Fair Chance Learning. We do a lot of presentations together now. He's
awesome. Yeah, that's great. Yeah, I've known Brian for a while. Anyway, welcome to all of you from right across the province, and a really warm welcome to Lisa. I'm going to turn my mic off now. I am behind the scenes, though, so if you need anything, just put it in the chat and let me know.
Okay, thank you so much, Susan. And actually, it's funny because Brian mentioned you to me and said how amazing you are. So I thought that was kind of neat. Okay, so thank you so much for joining me. I will just put this back up here. So you can see that if you'd like to connect on Twitter, it's Lisa Ann Floyd and with an E. And I know some of you already, we connect together already on Twitter, so I'm so pleased to see you all here today. Just a quick background. So as Susan said, I am working full-time right now for Fair Chance Learning, an amazing company. I feel like I have a dream job. I get to work with students and teachers all across Canada, and I do a lot of stuff with STEM, computational thinking and coding, and it's a pretty awesome job. Yesterday we were in London, here where I live, with 14 different school boards represented at an event, and it was just an amazing day, so much energy from all the educators. I also have actually been working at Western University. I've been teaching computational thinking and math education, and it's all of the primary junior teacher candidates take that course. So that's over about 200 of them take that course with me, and it's a 9-week coding course, and we integrate it, or help them to integrate coding into their math classes. I also have the privilege of working with a couple professors researching computational thinking, and so I'm a research assistant for them. And I'll share some of the stuff that that I've had the privilege to be a co-author on with you this evening, just some research that's relevant to what we're learning about today. And I'm just on a leave right now from Thames Valley District School Board, so I taught there, or I've been teaching there for about 13 years, 14 years, I guess, computer science, math, and science. And more recently, the last few years, I've been going into elementary schools just because I absolutely love it and really believe we need to expose our younger students to coding. And I'll talk a bit more about that later on. So thank you again for joining me. I'm going to get started right into things here. So I should have to, there we go. So before we begin, I do want to suggest, I'm going to be doing a few slides where I'm just talking about computational thinking and the benefits of coding in your classroom. So I do want to suggest, I recommend that you have a second device if available. It's certainly not necessary. You will be watching videos of this evening, so you don't necessarily need this app, but if you'd like to follow along, you would just need an iPad. So the ScratchJr app is what we're looking for. It's all one word, ScratchJr. It's different than Scratch, which we will also be doing for those of you who are on a computer today. So on your iPad or your Android tablet or a Chromebook, there is an app called ScratchJr, and you can download that if you want right now as I'm speaking. But again, it's not necessary. It's just kind of neat to follow along. It's a really popular app for primary school students for learning how to code. It's actually a sandbox-style app, meaning students can create their own things. They're not actually following a tutorial to create these things. So it's an awesome app. I really recommend it. And I think after you see the short video clips of it tonight, you'll also want to give it a try if you haven't already. So ScratchJr, and Susan's put that on the window, so I can move on to the next slide here. So you've probably heard the term computational thinking, or at least you've heard of coding. And what we're doing is using coding as a context to develop our students' computational thinking skills. And computational thinking, there's so many definitions out there. But what I've kind of looked through them all and picked what I believe encompasses all of the terms, or what terms encompass computational thinking. And one of those is recognizing patterns, sequencing, breaking large problems into smaller parts, which those three things are actually, as you probably know as primary school teachers, are pre-reading strategies. So even if you're not doing coding for math, you're actually, if you're doing those things, you're preparing your students to be better readers. And there's also, so for sequencing, I'm going to give you some examples of what you can do related to coding this evening. And the whole idea of breaking large problems into smaller parts, the term that we use for that is decomposition. So I'll be talking about some examples of how you can do that with ScratchJr this evening. Students, often in math class, we have students following algorithms to solve math problems, whereas when we're coding, students can create their own algorithms to solve problems. Once they get more comfortable with coding, they're able to write coding programs to solve math problems. Now, algorithms are step-by-step instructions for solving problems, so for example, or step-by-step instructions to complete a task. So for example, if you're following a recipe to bake something or cook something, that would be an algorithm. In math class, we sometimes have algorithms for completing long division, the step-by-step instructions for doing that. What I like about coding is students are creating their own algorithms to solve problems, and that can be very powerful. I'll talk a little bit about debugging tonight. So when we're coding, students often make mistakes, a lot of mistakes, and they have the opportunity to fix those errors, and there's definitely some value in recognizing mistakes as opportunities for learning. Abstraction, I'll give you a definition a little bit later more this evening, and I'm sure you've heard of it before, but a simple example would be a young child who, perhaps like a 1 or 2 year old who sees a dog, a poodle, and says doggy, and then a couple of days later they see a golden retriever and they still recognize that golden retriever as a dog. They've abstracted, they recognize that the poodle and the golden retriever are still dogs. They're not calling it something different like a cat. So that would be an example of abstraction. But all of these things are part of computational thinking, and we should be fostering our students' computational thinking skills, and I'll give you some ideas tonight. Hopefully that will help out. So computational thinking research shows that it does have a powerful impact on all areas of students' learning. So if we're using computational thinking in our classes, they can actually do better in every subject area. So it's quite helpful to be doing that for our students. Now, I like to think of computational thinking and coding as helping our students to be better thinkers. And I have read this quote a couple of months ago in a math article by O'Brien, and he said that math should make sense to children. We should encourage them to be thinkers rather than storage bins for thinking done by others. It's one of my favorite quotes. I like to share it on webinars just because I think, and when I talk to teachers and share that with them in person, I see a lot of nods because this is ultimately what we want to do for our students, help them to be independent thinkers. So the focus is on math. Tonight I will give you some cross-curricular ideas as well, but coding makes sense it makes sense to use coding because we're giving our students a meaningful context for learning math concepts, and vice versa. By coding to learn, we're giving our students a meaningful reason for learning to code. So it works both ways. So math can be integrated, or sorry, coding rather, can be integrated into all subject areas, but it just makes a lot of sense to do it in math. You'll see so many logical ways to do it, and it fits so beautifully together. So I thought we would do a little poll just to find out what your coding experience is to this point. So I'd like to know if it's limited, some, considerable, or thorough. And I'm going to ask Susan for help just to explain where I explained the polling tool
when I was doing the tour. So it's in the communication icons above the list of participants,
right,
so that people are finding it. The one that we had before was the green check mark and the red X. So you're going to choose instead. I've switched it to ABCD. So, and it will show up beside your name. And if you'd rather, I see
Awesome.
a couple of you have put marks on the screen. That works too.
Oh yeah, no problem. Okay, so it's quite typical that when I ask this question, a lot of times it's A or B. So it's interesting to see a couple of thorough on there. So awesome. Feel free to add your 2 cents throughout this webinar in the chat window. Okay, great. Okay, so a lot of people, most have done some coding. And hopefully I can present some ideas to you that will be for all levels of readiness when we're doing this webinar this evening. So thank you for taking the time to fill out that poll. And I'd also like to know if you've done any coding with your students in math class. So yes, no, or not applicable because you haven't done any at all. I'm just curious to know. Okay. So I see some yeses, mostly no's, and hopefully whether you've done it or not tonight, I'll still be able to give you some more ideas. So thank you for taking the time to spell that out. Awesome. Yeah, procedural writing is a perfect opportunity for you to incorporate coding into. I agree. Thank you for that, Allison. And it's great because I'm not actually going to talk about that much tonight, so it's good that you brought that up. Thank you. So this is just a screen print directly from the Ministry of Education math curriculum for grades 1 to 8. It does recommend that, this is like the format, we call it, in the curriculum, and a lot of times, especially teachers just starting out, we tend to skip all that part and go right to exactly the concepts that we're supposed to teach. But if you read through that whole beginning part, or if you haven't read it in a while, you might want to read through it again, because it's actually beautifully written. There's so many wonderful ideas in there. So the manipulatives, when it talks about manipulatives as being concrete learning tools to make models of math ideas. And when we're coding with our students, that's exactly what they're doing. They're actually making models of their ideas in coding, and it helps them to understand that making models provides a meaningful and powerful way to describe their understanding. And what I've noticed with students is when they're coding, you can actually have a nice visual of the connections happening in their brain. And when you go and ask them what they're doing, they start talking about their math learning. And so it might not be totally obvious, especially when beginner coders or teachers who haven't done much coding with their students. When you ask the students to talk about their thinking, it's pretty awesome. You can really get an idea of what thinking is going on in their heads, and you can catch some preconceptions and misconceptions as well. So we consider coding as a powerful manipulative when we're doing it in our math class. And research shows that coding actually does, sorry, my computer just froze there for a second, actually does resonate with traditional manipulatives, and they're similar to blocks, counters, and fraction boards, which have shown to be supportive of young children's learning and creative expression. So it's an awesome idea. Okay, so let me just move on here. Okay, so the math processes, I'm sure you know, it's in the beginning of every section of programming, of the math curriculum. And these processes, problem solving, reasoning, reflecting, connecting, it's at the heart of coding. So when you're programming with your students, all those ideas is what we do all the time when we're doing computer programming. And there's definitely, I find when your students actually notice that there's value in coming up with multiple ways to solve problems as well. And you'll see that when you're coding with your students as well. So everyone will solve the problem in a different way, and it gives you an opportunity to have a math discussion in your classroom. So I have to make sure we take advantage of those opportunities for the students. So I'm going to start off here with a patterning example, as tonight we're focusing on patternings as well as movements on a grid. And today we've got the we're going to talk about grade 1 expectations and grade 2 expectations. I just pulled those ones out because for the activity that I'm about to show you, we actually hit on pretty much all of these expectations. So these are the expectations taken out of the Ontario curriculum for grades 1 and 2 for patterning. Now to do this, as I mentioned, if you have the ScratchJr app with you on a Chromebook or an iPad or some sort of tablet, you are going to take the time and watch this video yourself right now, because it does explain to you how, so I made this video, it explains to you how to make a pattern using ScratchJr. And there's just a couple, you can actually see the code on my screen right now. There's just a couple of blocks required to do this. So I would like you to take that time to type that bit.ly into your computer web browser, whichever one, just start a new window, and you can watch the video yourself, or you can watch it on your tablet, but it would be neat if you watch that video on your computer and then complete the tutorial if it's just a 2-minute video.
The link in the chat is active,
go ahead
so
and
you
do
can
that
just
now.
click the link in the chat and you don't have to type anything.
Perfect. So we'll wait till you're done. And I know, Susan, you suggested sometimes people put a little check mark when they're done, or...
Yes, I've changed the polling tool
maybe
back to a green checkmark red X. So when you have finished watching the video and tried the tutorial yourself, come back to Blackboard and just give us a check mark, and then Lisa will be able to judge when to move on.
Thank you. So it looks like a number of you have finished. I'm just going to turn down the volume on my backup computer here so you don't get feedback. There we go. So it looks like a number of you have finished the tutorial. Can you just indicate in the chat window if you were able to finish it somewhat successfully? If you were able to actually try out the program? Yes, no, or any questions at all? Please feel free to ask in the chat window. Yes, Jan, that makes sense. Allison, as far as the individual accounts, I've never used individual accounts with ScratchJr, so with the primary school, I haven't done that. If you keep track of which iPads they're using, the previous program that was on there will still be there. So you could number your iPads and have them use the same iPad each time. So Fish didn't return to the starting position for Melanie. So at the top, I can actually show you with this little icon here. So right here is where you would click, and that will make the fish go back to the starting position. So that should work. And then you can run the program again. Okay, so I'm going to go to the next slide now, and feel free to ask questions as we go, and if I miss any, I'm sure Susan will let me know. So for this one here, we're going to try watching this together because I'm going to talk over the video. So I'm going to see if we're going to try this. I'm thinking that Susan might bring this up, and then I will talk over it, but I can certainly bring it up if that makes it easier, Susan, whatever you think. There we go. She's already on it. So I'll just talk about this one. You don't actually have to do this one. It's up to you. But just to make sure we're going through. So for this one here, I'll just pause it for a second. I'm making an A, B, C pattern, and I've used a loop to replay the pattern over and over again. So students, you can see the yellow blocks. I have the loops on them. And then I also have, or I guess the orange blocks rather. And then we have a loop inside of a loop, which is actually a nested loop, which is normally a complicated concept in programming. However, it's actually not too difficult in this. And what this does is, so you can see this blue, the first blue block, it looks like a little arrow going down. What that is doing is it's actually jumping, and it's jumping at a height of 5, and it's doing it, the repeat beside it says 4 times. Then it's going to move forward 3 steps, and then it's going to do a full rotation and do that whole thing over again. So let's watch what that looks like. It's a little bit laggy, but that's okay. There we go. And then it just does it again, and it will do that 4 times. And if it continues to go on, it will then go back to the fish will then go back to the other side of the screen. And you can get rid of the code, and the students can just look at each other's and try to figure out what's happening with that. So we can go back to the slides now. But the students can watch that, and watch each other's programs and try to figure out what the pattern is. So it's almost like a challenge, so they can swap programs and try and figure out what sort of pattern is happening. Or they could try and recreate it without being told what their partner's pattern is. So it's just an idea to try. Now, the ScratchJr Blocks are actually available online, so you can do this in an unplugged way. So I actually have a picture of my husband in here, and he did some work with, actually, I know Donna, I saw Donna on here. So I'm going to talk about Donna a little bit later, Donna Forrester. So she was doing some work as well with Steve, my husband, and I'll show you his Twitter account in a second because I'm borrowing some other stuff from him as well. But you can print these blocks. And if you go to this link that's at the top here, or find it on the ScratchJr website, oh, and Susan's already posted it, thank you, Susan, you can find all those blocks and you can print them in color and laminate them if you wish. So that's quite useful, because then you can do some of this activity without having to be on the ScratchJr program. So a little bit less screen time, but you're still having your students use the logic. So this is not a math test, but it certainly will support your students with learning math if you do it. So this is a storytelling idea, and I give my husband credit for this because I do get a lot of ideas from Steve. So Stephen P. Floyd is his Twitter account. So what he did was suggested doing this for grade 1. So you would probably read this for your students. You wouldn't have them read this themselves, depending on the ability and the readiness and the students in your class. But so here we say, Frederick was a little green frog who loved to spend his day hopping. One day Frederick walked to his bed and climbed on top. He hopped 3 times on his bed, but on the 4th hop he fell off and bumped his head. After that, Fred has decided to only hop when it's safe. What a smart frog. So what you would do then is break up this program into separate parts. You can actually go and draw on it together, or you can talk about it. I'm just trying to get my drawing tool up to see if this works. There we go. So you could have your students break it up together, or you could have images of these things on the board. So it just depends on what grade level you're working with. With the grade 1s, you'd probably use images, and grade 3s, they can read that okay. And then I'll show you what we'll do next. So then you would have them program this in ScratchJr. So everything in that story is possible to do in ScratchJr. So then you can go ahead and have them program it as this is done here. So they programmed the frog doing all of those. You can see the picture of the frog there. Let's grab my other icon. So you can see here's the frog, and then we programmed him to do all of those things to tell the story. So then they can watch each other's story, and that's sort of more of an intro to this activity. So they would do exactly what you say, and you decompose the story into separate parts to help your students break it down. So that's important for pre-reading as well. So then you give them a little bit of a more challenging story to make with a little bit more things happening. As again, this is a story, so this is about a fish, and all of these things are possible for you to pull up using the background and the sprites, the little characters, we call them sprites. So then you would have them program that using ScratchJr, either in partners or separately. And again, you can see that there's the background and the fish, which you've already seen in the video. Then you give them the option to create their own story using ScratchJr. And what's really cool, in ScratchJr you can record your voice. So you would just go to, I'll show you later on in a tutorial, there's a green sound block, and you would click on that sound block, and the students have the option to record their voice. So that's one of their favorite features of ScratchJr, to make the little characters say things to one another or make funny sounds together. So the students have to really think about their story, plan it out ahead of time, either by talking or drawing a picture. Then they code it in ScratchJr, or write it out in words first, then code it in ScratchJr. Play the program for a partner, so here's just an extension idea, but don't tell the partner the story, and then have the partner write down a story based on that program. And then you compare the stories, and of course it might not be that they're writing, but they might try to tell their partner what they think the story was about and see how similar the stories are. So that just takes it up a notch to another level. Okay. So moving on, well, before we move on actually, these expectations are all taken from oral communication and media literacy. So by doing that activity, you're covering those expectations. So oral communication and media literacy in grade 1, but they're similar across all the grades in primary and junior. So you could do something like that and cover all those expectations. When you're doing this sort of thing, you'll find there's a lot of opportunity for just-in-time teaching. So your students will try and do something, and you'll hear one of them say, "Oh, if only I knew how to make the little character, you know, spin around fast." So then you would come, I would come with like a fairy godmother and say, "Oh, funny, you should ask," and then I would tell them how to do it. So you're almost waiting for them to ask how to do something, because, and then it's more authentic. They're really curious about it, and then it's just that they're seeking out the answers now. And yes, you can record your voice in Scratch as well. Thank you, Karen. And I'll show you that tonight, or I'll show you where you would do that. And right now I'm going to show you that. So I might as well share this program with you. Actually, we'll watch this video together, and then I will show you how to make this. It's a very simple program in Scratch. And I know I said we'd focus on ScratchJr tonight, but I would like to just show you the possibilities of Scratch, because I've seen a lot of success in primary grades with Scratch as well. So this is a 12-second video, and it's a pattern, so there's a picture of me. And what it is if you look in the screen, you can see a repeat. So it's going to repeat the pattern 3 times, and it's going to show 3 different images and play 3 different notes. You can see that it plays note 60, and I'll show you on my screen in a second what note that would be. So let's just play it, and you should be able to hear the sound as well. So when I click on that part, you can see that 60 is little c, or is middle C, as it is in all programming languages. So just watch that one more time, and then we'll get off there.
Yeah, sorry, I think that's one of the things that happens with WebTour is that not everyone's seeing the same thing. It's not like sharing your screen. So it goes through the videos that are coming up next. So I'm seeing the comments in the chat, and that's what I've heard has happened.
Okay. You're seeing it. Oh, okay. All right. So so for the rest of them, then we'll have them watch it themselves on the link. Okay, good to know. Thank you for the feedback, everyone, too, so that we know. Okay. So for this one here, we're going to actually make this now anyway. So I'll be able to show you. So we're going to, now you can watch me make it. I'm going to share my screen with you right now, and let us know on the chat window if it's too laggy or if it's not working. And we have kind of like I've lots of backup ideas here. But I'd like to try to share my screen with you. I think it will be a neat opportunity for you to try to make this program. So you can either watch this program, or you can watch what I'm doing right now, or you can play along with me and try and do it. So for this one, you can see on my screen, you're going to go to scratch.mit.edu. We like it to be a little bit of hands-on here. So scratch.mit.edu. And for this, you have to be on your computer or a Chromebook. So this is Scratch, not ScratchJr. This will not work on an iPad. So these are things that if you're going to be doing coding with your class, you'll start to learn that, you know, what works on each device. So Scratch, sometimes I just Google Scratch and then I get to it that way. So I'm going to be sharing my screen now. We'll see how this goes. We did try it earlier and it worked out well. So I'm waiting for the options. Okay, it says hosting is paused. Oh, can you see my screen now, Susan? Oh, I can see it online. Right. I can actually have that ability. Oh, nope. Okay. So it's sharing. So it's sharing a different program here. So I'm just going to see if I'm able to switch it. Okay, I'll just go to File, New.
You should be able to just switch it, and we'll see whatever you are displaying on your screen.
Yeah. Okay. Right now it's not giving me the option, so I'm just going to. Okay. So it's just doing a screen print of my last one, so I might actually skip over this. So that what I have on my screen right now is not what's on. That was where we left off before. So I'm wondering if it's just paused. Let me try. Oh, there. Oh, yay! I think this is going to work. It seemed to have remembered where I was before. So select Start Sharing or Switch Mode. Okay. There we go. Technology. We have to be patient. We can't give up. Okay. That looks good. Okay. So I can see what you can see now, so this is great. So this is the Scratch environment. Some of you are familiar with this. And what we're going to do is go to Events. So on your screen, you will see a number of what are kind of like drawers, and they're all different colors. So within each drawer are a number of blocks that you can use. So we're going to be clicking on the Events drawer right now, and in the Events drawer, you can see they're all kind of an orangey brown color. We're going to grab the When the Green Flag is Clicked block. And I'm going to make my code a little bit bigger. Okay, there we go. So once you grab the When the Green Flag is Clicked block, we can then go to Control. And so just type in the window. I know some of you have used Scratch before, so you can feel free to answer the questions as well if I miss them. But we're going to go to Control and grab the Repeat block. So under Control, Repeat block, and you will see, yep, it's just lagging, so I'll just do that slower. So you'll see that the Control ones are more of an orange color. And we're going to change the repeat rather than 10. We don't want our program to repeat too many times. We'll change that to 3. So the next step, we have a couple more steps here. Right, this is done on the online version, not the app. Sorry to use them interchangeably, Jenny, but I think it is worth it to see the two different applications and the possibilities. So it's just, if you just Google Scratch, you can get right to Scratch. So we're going to go to Looks now. And because you'll have all of these resources shared with you later, you can watch this video and it shows you, and you'll figure out how to do it. Okay. So now you can go to Looks, and we're going to switch our costumes. So I'm just going to, what we'll do first actually is you click on Costumes at the top so you can see the Costumes tab, and you can see my mouse is on it right now. We're going to click on that, and you'll get to a new screen. Now you have a couple options here. You can add sprites. So if you click on this little icon here, you can add new sprites from a library, or what I've done with students, and they seem to enjoy this, is take a selfie. So I don't know if this will work since I'm hooked up to, oh goodness, I've been like messing my hair up, so I don't know what I look like, but I'm going to try this right now and see if it works. So I'm going to click on the camera. Since I have multiple applications open, it might do something funny. I'm going to click on the camera, and you have to click Allow to allow your camera to be used. Students love doing this. I've done this a number of times. So you click on Allow, and so you can see me. There's me. Yep. So it's just lagging on your screen. But then you click on Save to take the picture. Okay. Well, we're going to stick with my half-opened eyes there just to save time. So I've taken a picture of myself. That's going to be my first image for my pattern. I'm then going to I'm going to take a second image. So to do that, make sure you're in Costumes beside the word scripts at the top here, because some people will take a picture with this camera down here, but that will actually add a new sprite, and you don't want to do that. You want to work in the same sprite. So while you have the sprite selected, you go to Costumes, as I have here, and then click on the camera. So we're going to click on it again to take a second picture. In this one, I'm going to do a different symbol. We'll click on Save. I'm hiding in the basement. It's almost like a closet where I am right now because we have 3 children upstairs. Okay, so there's my second photo, and I just clicked on Save, and then I'll do one more so I have 3 different images. So I'll just do something like that. There we go. So I took my third picture. And what you could have your students do next, depending on the grade level, you can have them name each of your photos. So you would just click on the first photo, and you would name it in this window up here, in this field here. But if you're working with younger students, to have them name their photos, depending on what the purpose of the activity is, that might take a little bit extra time. So I'm just going to leave that today. Right now they're called Photo 1, Photo 2, and Photo 3. I'm going to go back to my code now, so I would click on Scripts. And here, I'm going to switch my costume between 1, 2, and 3. So I'm going to move my under looks, grab the switch costume to Photo 1. I'm going to grab that same block again, switch costume to Photo 2. So this is all under looks. And one more, switch costume to Photo 3. And now I'm going to add the sound that you saw, some of you saw in the video. So some of you, this is going to be a surprise video because you were or a surprise program. Surprises are good. And we're going to be playing a note. So if you select something from the sound menu that actually has a number of beats, that will make it so it will play the beat, then show the next picture, play it for a beat, then show the next picture. So make sure you choose something that has a beat for now. So I'm going to select play note 60, which in programming world, note 60 is always middle C. And there's actually a reason for that. So that could be a whole other webinar connecting music and coding and math together. So you can see here, if I click on the little pull down menu, middle C will show up. So I'm going to grab another one. So play note, this is all under sound. And I'm going to do the letter E, so 62. That's not E, that's D, but that's okay, we'll leave it at D. I played by accident, so now I'm going to do one more note, so a third note, and I will change that to E. So let's try running that program and see if it does close enough what we want it to do. So when we play the program, it's just delayed on your screen, as I can see, which is fine. When you play it, you'll actually see, if you're doing this live yourself, you'll see the note and the picture change at the same time. But that's the code to make that happen. And what you could do next with your students is some of them will go outside, take pictures of themselves, like playing soccer, doing kick-ups, and they could program themselves doing a whole bunch of kick-ups and repeat it like 100 times to make themselves look quite skilled at soccer. Or you could have your students program themselves doing a dance. So that just adds a new element to it, and they could have a whole bunch of repeated patterns for the dance. So Scratch can be used successfully in the primary grades. You just have to, take your time, and the first time you do it might be just logging on. The second time you do it, there's other ways to try it as well. Okay. So let's go back to, I'm going to stop sharing my screen and see what happens here. Application sharing has stopped. Let's see if this works. Yay! Okay. So, and just ask any questions as we go. So that is a fun activity to do with students and teachers. Yay, it worked. Okay. Yes, Susan, I was excited about that. So I'd like to talk a little bit about some of the unplugged activities that we can do. with our students. And the wonderful example for patterning is one that Dr. George Gadanidis has on his website. And I'd like to share this resource with you because it's awesome. You can get to it by typing in researchideas.ca, but to get to the exact example that I want to, we're going to be going to this bit.ly/pattern example. And I will walk you through. I'm going to try sharing my screen for this as well, but you can actually just look at the link yourself. So don't worry if this doesn't work, so just follow along. So you'll click on that link as Susan has made it a clickable link, and I'll see about sharing my screen. Might as well. Now I know how to do it a little faster. So if you're already on the link, you'll see at the top a xylophone. And so the first thing that you'll do is have your students make a pattern with a xylophone. And they can do things like, so it's waiting for applications to, it's waiting for it to start. Hold on. I'll just make sure that I haven't missed a step. Oh, if I click on the word share, that would make it happen. Okay, and I just have to get over here. Okay. Yay, you can see it. So in the example on here, you can see that it says red, red, blue, red, red, blue. So the students express this pattern in 3 different ways. And some of you might have done something like this with your kindergarten class already. But you can play it on the xylophone, and I'll show you where you can find a xylophone in a second. And they can sing it, so they can say blue, blue, red, or whatever it is. Excuse my poor singing. And then they can stamp this pattern on a piece of paper as well to get used to repeating the pattern. Then, as you can see, I'm scrolling down. It then has, you can have these mats. I have lots of these in our basement in our home gym that hasn't been used very often lately. And you can have your students jump to do the patterns, so blue, blue, red. Finally, the next step, well actually one more after this, you can see as I scroll down, they would stamp out their pattern, and then they can cut it out, so they cut out the repeating pattern. But I'm just going to show you a grid here. So I'm clicking on the left-hand side to grid, as you can see. So there's, they've cut it out. Now there are there is a printable for this grid, but you could make one fairly easy. So you can see that on his website, he has a grid handout. So you can print this off, and what you do is have the students first write out. So this pattern example here says green, green, red, red. So they've stamped that on this part here. So green, green, red, red, green, green, red, red. And that's with 2 columns. Then you have them do the same thing, but with 3 columns, green, green, red, red, green, green, red, red, and they talk about the pattern that they see here. Then you have them do it with a wider grid, so it says green, green, red, red, green, green, red, red, but notice that you start to see some diagonal patterns happening, and that tends to be a surprise for students, and Dr. Gadanidis really likes the idea of giving students mathematical surprises, and he says if they already know the ending to the movie, what's the point of watching it? So it's kind of fun to have your students try something like that. I'm just going to show you one other thing. There's an extensions option here, and you can use this app here. I think it will display nicely for you. So you have, if it loads, there we go. So this is a little activity that you can try with your students. But I'm not sure what grade you might want to try it with it. But right now we have a grid of 1, so there's only 1 column. The core length is 2, so our pattern is green, red. And so we want to try and adjust it so that it's right. So we're going to click on the green and then the red. We have to change our color. So the students are trying to make it the exact same as the photo. And so our repeat, you can see that there's only 1 of it. So I'm going to change my repeat to 1, and then you can test it. When I didn't do that before, so that's kind of neat. So then you can click on next, and the students can go through all of these activities. So here we have a pattern of yellow, blue, yellow, blue, yellow, blue, yellow, blue. So the core length is 2, the grid is 4, and they're trying to to replicate that. So you would click on the little dot and then change them until you get the pattern that they see. And then they have to figure out how many repeats that is. So we can change the number to the number of repeats and then test it out. Doesn't matter which way they read the pattern. So they have to read it from left to right. And if they've already stamped it out, they'll be used to going from left to right on the grid for this particular activity here, because this is the program that's been written. Okay? So that's just an extension, and it gets a little more difficult as you go. So I'm going to show you. You can see I have the xylophone open already, but there is a bit.ly, and I'll show it to you on this screen that on the PowerPoint in a second. But because I didn't have a xylophone when I went into a class, I just made one on Scratch. So I just wanted to share this with you so that if you want to do this sort of activity with your students and you don't have a xylophone available, although it's a wonderful instrument to have in your class, you can just use the Scratch version and it works just the same as. So then you get the students, oh, thank you, Susan. There we go. So I just did my pattern there. Okay, awesome. So I'm going to stop sharing and return back to my slideshow now. So feel free to use that Scratch. And you can look at the code to see how I made that. It's very simple code. Okay. There's a lot of other resources as well on Dr. Gavin Youss's website, so feel free to check those out. They're freely available to you. We're going to have a look now at movement on a grid. And I just pulled out some of the expectations that we're hitting. And it's really important as teachers that we know what's happening across the grades, because then we end up helping our students and supporting them with understanding what's happening across grades too. So even if you're teaching grade 1, you should know what's happening in grade 3, so students can start to see those connections between grades, and it starts to make a little bit more sense. That's what the research shows, that they need to see those connections, and as well connections to real life. So we're looking at relative location, so positional language. We're also looking at using a grid. Okay, I'll go to the next one. And some more movement on a grid. And you can do all these unplugged, and I'll give you some more unplugged examples as well. Thanks for sharing that, Lisa. I get to know about music sparkles. So for this one here, you are going to watch a couple of videos on your own right now. So this will take, each video is about 3 minutes. So I will stop talking for about 6 minutes in total. So you'll do the first one, so ScratchJr Grid 1. And it's awesome because Susan can post those links for you. Thank you, Susan. And then you can, after you've done the first one, either just watch it or try it out on your iPads or your Chromebooks as you watch the video. And you can pause. What I like about the videos is they can pause it and go back and replay, and then do the second one as well. And if you want to put a check mark, which is right above the participants area, there's a check mark there. You can select yes or no, or yes, just to let me know when you're done. But I'll reconvene in approximately 6 minutes. But I'm still here, so feel free to ask any questions in the chat window. I can see some people are starting to finish. Just feel free to ask me any questions that you have while we wait for others to get the chance to finish. Okay, just about everyone is finished. So hopefully you were either able to just watch that or even make that activity successfully, and I'll be coming back to it for an extension idea in a bit. Before I do that, I thought I would talk about transformations and the option to use transformations or to use ScratchJr to demonstrate a transformation for your grade 3 students. So they do have to do flips, slides, turns, and they can do this through investigation using motion. So obviously it's awesome to do dances with your students, but it's also awesome if you can do them with ScratchJr as well. So for I have to give credit again to my husband for this one, because we share a lot of ideas, but this was something that he did with a class the other day. So he's a high school computer science teacher as well, but goes in and helps younger students. So we're going to look at a translation, so moving from one place to another, from one point to another, a rotation, so spinning, and then we're going to look at a reflection, and then we can have a look at resizing. So those are the transformations that we're going to do now, and I'm going to go to the next slide here. So someone needs to give Stephen P. Floyd a shout out on Twitter to prove that I do give him credit when I use his materials. Okay, there we go. So here is what you would do in ScratchJr. And so this one here, you can see to do a translation, you just use the move block. To do a rotation, you would spin. To flip, you can just use the block, go one way, then go the other way. And then to grow, there's a purple block that you can use. And rather than have you watch that video and do it yourself, I'm going to keep going just because of time. There's a couple things that I would really like to get through to show you. So you have the video, you can save it. They're all on the same YouTube channel as well. But it just is me explaining what I'm just showing you on the screen here. So you can see the arrow for the translation, move from one point to another. The rotation, we did that already with the patterning anyway. For the reflection, you would just type in 0 in there so it doesn't actually move and reflect, and then resizing. So it's a neat way to have your students do this in the actual program. So you would give your students instructions to try and do all of these things. And then you can have the students loop the program and see if they can add sound, naming each of the transformations. And you saw the pop in the previous video. Well, rather than the pop, you would have the students record their voice, and they can explain what's happening for each of those transformations. So I'm going to talk about the traveling salesman problem. It's a classic algorithm that is, people are trying to solve this all over the world. And what it is we're trying to figure out a way, if you're a traveling salesman, to go from your home and to get to all of the points around the world and to find the most efficient way. So it's an optimization problem, and it's a classic algorithm for computer science. It's something that no one's been able to solve yet. They can only do it right now through brute force or through kind of figuring out how to do it. But if you are able to come up with a solution, the Clay Institute, Mathematics Institute, will pay you $1 million if you could come up with the most efficient way to solve this problem, finding the shortest route to take that will apply for all options. So far, we don't know of one that exists. I'm just going to show you here. Let's say we only had 3 points to get to. So here's our traveling salesman. I'm going to just grab my little point. So here's my traveling, Okay, here's my traveling salesman, and he's trying to get to each of those points. Well, when you only have 3 cities to get to, then it really only is 3 options. So that's not so bad. But then when you want to get to 1, 2, 3, 4, 5 cities, then there are 60 possibilities. So you could still do that successfully through brute force. But what if you wanted to get through, well, if you go up to 6, then you're at 360 possible routes. But if you go up to 10, then you're at 1.8 million possible routes to try and find the most efficient way to get through. So that would take a couple of days to do that, even if you're doing, a couple per second. So it's not practical to figure out the most efficient way using brute force. So there's a way that we can apply this to real lives. And actually, what we could do, and I'll just describe this video for you. You can watch it later. It's kind of a neat algorithm video. So it's taken from a video called Algorithm, a documentary, and it's Really, really interesting. It's on Netflix, so you can watch it. It's on YouTube. The link is there if you'd like to watch it another time. I was going to show you a bit of a clip of it, but what it is it shows bees trying to do that. So they study how bumblebees would tackle the traveling salesman problem by planting. They're not using actual flowers, but they're using, they put sugar at each of the locations to make it look like flowers. And they record where you can see on this bee here, they actually have a little transponder to track where the bumblebees are going. And they watch the video, or the bees, for quite a while, and then they realize that what happens is the bees start to get more and more efficient. So it's really curious because we're thinking that maybe the bees have solved the traveling salesman problem. Not quite. They never actually do the most efficient way, but they do get very close to the most efficient way. So usually bees have to hit around 100 flowers each trip before they go back home. And so it's a really neat way to see if, are they doing this efficiently? Because 100 flowers is a lot of flowers and they don't want to waste time. So what we're going to do is watch, you're just going to watch on your screen right now. I'll just show you here. So that previous video, you can watch the algorithms. But this one here, so I'm just going to put a sign here. This is a video, a very, very short clip, and there's not any talking on this. So I'm going to let you guys watch this, and then I will talk. So if you just type in that in your browser, you'll come to the ScratchJr Bees video, and it shows the bee, what you can do with your students to have them solve the traveling salesman problem, and then I'll talk a bit more about that. So go ahead and watch that short video clip now, please. Deanna, you're watching the one that's just above where you wrote that question, so ScratchJr Bees. Sorry about the confusion. I just realized the time is running out, and you can watch the other video later. So the ScratchJr Bees one, the one that's up on the screen. No problem.
Lisa, did you see Joe's comment about the link? And I just tried it, and it did the same for me. So we'll have to fix that link before we...
Oh,
yeah.
Okay, the bees algorithm one? Okay, I didn't see that, but thank you. Yeah, I'll double check that after. And actually, if you just go to YouTube and search for algorithms documentary, Joe, it will...
I'll do that and put the new link in.
The bees algorithms, but I can... Okay. Okay, thank you. Yeah, I must have made a mistake when I did the bit.ly. Sorry about that. Okay, so I know that video was about 30 seconds, so you guys should have had enough time now to watch that one. So what you saw there was, well, we used decomposition because we had the students break it down into separate sections. So the bee started at the bottom, they had to figure a way to get to the purple flower, then they had to figure a way to get to the red flower, then the yellow flower, and they chose the option. And you'll find that your students will all do this in different ways. Some will be more efficient than others. Then you can talk about this and share ideas of what the most efficient way is doing. We use a little passing message, so that envelope is a way to connect sprites together, and so you can check out what that means. There's some ScratchJr tutorial videos on the ScratchJr website. So there's an individual code, so when the bee touches the flower, it will grow, shrink, and then pass the message that it's done with that one. Just going to go to the next one. So here is an example of the Beebot. So the Beebot I've seen have used very successfully doing very similar ideas as ScratchJr, but is a physical robot that you can purchase. It's a little bit expensive. It's around $120. I understand. I know Donna has purchased some, Donna Forrester. She wants to jump in. But you can go to this article, and it's an article by a teacher from out east, actually, Stephanie Collins, and a researcher. And she's done this with her students. And on that article, you'll see a little video. So you're welcome to check that out on your own time. I just wanted you to know that that article was available. So she took this little bee, and the students code it with arrows. And then you press the buttons on the top of the bee, as I'm going to show you in a second. And then it takes, and the bee will follow that route. So some ways that you can use this in your class. So this is actually our kitchen floor. And again, I give this credit to my husband. I was away when he did this. But so to get to the red triangle, they had to go up, up, right, up. And so it's almost like they're doing decomposition, breaking it up into 3 parts. First we get to the triangle, then we get to the square, then we get to the yellow square, or whichever way. So in this case, actually, it was to the yellow square and then the purple square. So red, yellow, purple. And you could laminate your arrows, put them on the floor, and then the students would then type in the code on the B. So this is a great idea to have as a center in your kindergarten class. And when you get more advanced, or maybe with your other grades, you can list sort of like an XY coordinate system. You can do A4 to B2, so you actually list the locations that way. So see if they can program the B to get through that way. And this is our 3-year-old who just turned 4 doing this activity. And it's really cute, actually. So you can watch this video if you want to. I actually might be able to share this. Well, it'll be lagged, so you can watch that if you want to. It's like a 7-second clip if you're interested, and you can see him successfully getting through the B. Where's the coded B available from? It's called a B-bot. Thank you, Sarah. And you can search for it. So they do sell it at Scholar's Choice, I understand. You can search on Amazon. Awesome. Thank you, Donna. That's a great joke. So you can see my son, if you watch that, it was just sometimes I use my kids as guinea pigs to do stuff, because if I don't have a class right now, then to try it out. Okay. So he was able to code the robot, and then you can get into other ways, like maybe they want to draw out the code with shapes. So they would say, okay, first I'm going to do orange, then purple, then red, then yellow to get to a certain spot on the grid. So it's just different applications to try that out. And what I've read in research, and we talk about this in one of the papers, is that these things are called digital tangibles. They're things that you can touch. They're programmable devices, and we've seen students really engage with just coding, but when you add a device that they can program and they realize they have the power to physically code something, there's even more engagement, and they're kind of more excited. So it's just some interesting research. And Seymour Papert is like the godfather of computational thinking, and he calls these objects to think with. So we did this as well, and I've seen it done in classrooms. We did this with beanbags in the classroom. And so here I had the grids made at my house. Like I said, I always test things out with my children first before we go out into the classroom. And sometimes we don't have pants on in my house, the boys, our children. And so here we have them trying to get to the objects, and we were just dropping dominoes to indicate which path they took. And then the challenge was to try and do a short path to get to the dinosaur, then to take the longest path to get to the dinosaur. And the point of the dominoes is to count your way through. Now, if you had multiple colors of beanbags, you can do like all red ones to get to the dragon, or the dinosaur rather, and then try it with, you know, a different color to see if you can get a different route. And you could take this even further, and you could print the grid out and then have the students try and draw out the path that they took. So they're looking at the big grid on the floor and trying to draw it on a smaller piece of paper. So that would be an extension activity for some of the students in your class. So I tried it with, at the time, my 3 and my 5-year-olds, and it was quite interesting to see the difference between, you know, one would do it most efficient way right away, and one would do it all over the place. So it's just neat to see that. So you can, I'm going to skip this right now just because of time, but I do want you to realize that you can do this in Scratch as well. And the Cartesian plane is available, so if you want to, you can check out these links later. They're all provided for you. The OTF webinars are awesome because Susan will go and give you all the links after, and it's all laid out nicely, so you can try that program out afterwards, where you're going to try and plot points in Scratch using the Cartesian plane. Now, what's really cool about all this is students are getting immediate feedback, and so they'll try and plot something. If you were to do this with a, say, a handout, and they were plotting all the points, you know, in the more junior grades, they might end up plotting all the points in the wrong spot. But then, and that would be frustrating by the time you get to help them, whereas when you do it on the computer and they're plotting points, they get immediate feedback, they know they've done it wrong, and they fix it. And what my 8-year-old actually said to me once is when he was doing some shapes, he said, Mom, there's a bit of a problem when we're coding. He said, it's great, however, the problem is everyone's going to end up with A's. And I was like, well, what do you mean? And he said, well, you see, when I'm coding and I have a mistake, I know that I need to fix it. So I fix it, and then I just keep fixing it until I get the shape right. And everyone will do that. So everyone will end up getting their shapes right. They'll figure out how to fix them, and they'll all get A's. So I thought that was just an interesting perspective. You know, if he was a little older, then we'd start talking about mastery learning, like perhaps we just need to give our students more time, and then everyone would end up with the right grade that we're looking for. At this time, I'd like to just give a shout out. So I'm going to talk to Karen. So Karen Enders, I believe she's still in here. Are you here, Karen? And so I've been working with a school board, and I mentioned I've been going, thank you, Karen, I've wandered around the country, and one of the school boards I've been working with is Superior Greenstone, way up north near Thunder Bay. So if you want to, I was hoping that Karen would just share with us for maybe 2 minutes. I know we're running out of time, but if Karen would just share with us maybe just her favorite activity or something that you've done. I know you've done some work with parents, Karen, so I was hoping we could turn on your mic and maybe we'll see if this works. If we have someone else sharing, we'll see if this works. Go ahead. Thank you, Susan. She will just let Karen grab the mic.
Oh, wow.
We can.
All right. Lisa has really been inspiring. I follow her on Twitter, so whenever she's trying something out with her children, we go ahead and try it in the classroom. But one of the first things we tried, we did a few unplugged activities, and that's a great way to segue into coding, is we mapped out a little table into the squares, just for quadrants, and the kids would use sticky notes. We put, I'd put jewels or a dinosaur or whatever, frogs in the middle, and they had to get their little man, or they have little minions that they move around, to the jewel or the selected object wherever I placed it on the board, and they would use a sticky note at the beginning for each move they made. So if they were going north, they would do an up arrow, or south, a down arrow, or left and right arrows. And they quickly caught on to left, right, north, south. We actually, it's really showing, like when we go on field trips and we're walking somewhere, they will actually tell us we're turning right now, they're turning left now. We brought the parents in and we played the games with them, because it's great and they can take it home and do it at home with their parents. Another one we did was your dot one that you had out on the Twitter, Lisa, and I created a couple more for them, and they would grab a line of, if you have large grid paper, just give them a line of grid paper, and they will code all the way down independently. And this is SKs for the most part, and 1s and 2s, but they quickly catch on to this. And now I hear how they have, when they have to go back and fix something, they just call it debugging. I'm just going to go debug it now, Miss E, and off they go. And that applies to any area in the classroom, not just for math anymore. So it falls into every subject matter. It really does.
Thank you so much, Karen. What you've been doing is really inspiring to me as well. And actually, the day that we did the one activity she talked about, you can actually see it on Steven's Twitter profile at the top. I did it, we were doing it like 9 o'clock at night, I think. One of our kids were up a little late. And then the next morning, she tweeted about doing it, and I was like, oh, that's interesting. Like, I thought maybe you had just done the same idea, but it was because you saw that activity and did it the next day with your students. It was really cool for us to see that. So thank you so much for sharing. I really appreciate that. So I'm just going to move on. We're going to go through, I'm going to skip to, I kind of put these in on purpose because I knew I might run out of time. And I'm going to skip down to here. And I'm just going to talk for the last few minutes about some other unplugged activities that you can do with your students. And to explain the reasoning behind it is when we're coding, there's something called sequential coding that you can do where every line is listed after another. So here's an example of ScratchJr. Here's an example of Scratch. So it's just one line after another. And there's a text-based language here, and Tickle, for some of you have used Zero. And what you can do in an unplugged way, and a lot of you are doing this already with your students, and I would say just do more of it. These are ways to develop your students' computational thinking. So doing your story maps, going through the first, second, third. We talk about these things with primary school. Keep those calendars and timelines going. Perhaps you can do some cooking with your students. Paper folding is an excellent way. Lego, following instructions, that's all sequencing. So it's just easy ways to incorporate this or do more of in your classroom. So when we get into some of the if-then, so this is when you're giving your, making your computer do a decision. And we use this language often. I'm just switching here. So when you give your students instructions, you might say, if you are finished tidying up, then go to the carpet. That is coding language. So we use that all the time. We usually will say, first do this, then you can do this. That is like a classroom management strategy. So those are easy ways to incorporate the coding terminology into your classes. Perhaps you might use it in daily decisions. So you look outside and just emphasize the word if. You can even have that written on the board. If it's sunny, then you're going to wear a hat. If it's rainy, or else if it's rainy, then bring an umbrella. So you can add these, make this even longer each day and help your students get used to this language. If, then, else, if, then, else, and so on, and then the students get used to that language. So another one is that we saw today was repetition, so using loops in our program. So programmers are very efficient. We never use the same line of code twice. So the beading activities, dancing, and recognizing that there's a lot of repeats in our dance moves. Maybe when you're planting seeds, you can emphasize the fact that you dig a hole, put the seed in, cover with dirt. Dig a hole, put the seed in, cover with dirt. So you could write that on the board and maybe use your Scratch blocks or ScratchJr Blocks to show that there's a repeat there. And those are easy ways to use Unplugged. Tweaking your current lesson ideas. So if you are doing sorting, which you need to do anyway, it's in the curriculum, what you can do is, if you have ramps, maybe you could suggest to your students to sort the cars according to how fast they are, change the ramp to make it steeper. Some of the work that I've done and learned through Dr. Kotsopoulos, who is was at Laureate, and she just went to Huron University, but she taught me that she does a lot of work with early years, early childhood education and math learning. And she said that when students are playing in the kindergarten, we know that it's supposed to be play-based learning, but the way to raise it up a notch, get the students thinking, is with your questioning. So you walk around and you just make one simple statement, like a suggestion to the students. Perhaps, why don't you try this? Or ask them questions to raise it up a level, and it gets them into higher order thinking. And all it is a question. I've heard of some students or teachers walking around with little cue cards to give them ideas to ask those higher order questions, and it benefits the students. They'll start to do something that they wouldn't do. So if you just let them play, it's fine, but when you come in there and ask them a question to take it up a notch, it really makes a big difference in their computational thinking and their mathematical thinking. So just keep that in mind. So we can see that in the curriculum we have to do sorting, and so another unplugged activity that you can do. So this is from the grade 1 and grade 3. So again, it's important that we recognize the curriculum across the grades and know when it's going, or when they're going to need to use it. So another unplugged activity is sorting objects. So just give them a bunch of objects. I know every kindergarten room has so many objects, and have the students, and some of you have probably done this, you give them the objects and then they have to try and sort them, and they determine the rule. Perhaps at first you'll tell them the number of rules, or they'll just come up with their own rules, and they can do this in groups together. And then the other groups come around and look at how the first group sorted, and they try to determine, and we've done this with teachers, and it's kind of entertaining, they try to determine the group's sorting rule. To extend this, you can give the group a few more objects, random objects, and have them add to their sorting pile. And they have to figure out, do they find out a good way to sort, or do they have to add a new pile? And when you're doing activities like this, again, this is all computational thinking skills you're developing. It's pattern recognition. The students are trying to figure out a way to sort things. It becomes more efficient. You're looking for similarities and differences. And we use pattern recognition in everyday life when we're recognizing facial features to recognize people. We're looking for patterns in data to predict when there's going to be an outbreak of illnesses. We're always using that for classifying data as well. And I talked earlier about abstraction. So when you're doing that sorting activity with your students, you're using abstraction to filter out ideas that aren't important and to focus on the ideas that are. A couple other tweaks here. So you can do, with your instructions, you can use what we call Boolean operators, so and or. you can say, you can use this when you're giving your students instructions. If you have a red shirt on or you have a blue shirt on, then go get your coat on. Or you might say, if you have jeans and you have white shoes on, these are coding concepts that we may not realize, but they're fundamental coding concepts, so Boolean operators we call them. So use the and the or. So those are the couple operators. A website you might want to check out. We're not going to look at it now, but I just wanted you to know that it's available to you. Thank you, Susan. So helloruby.com. And there's a book that goes with that, so you can, the book is kind of cute. You might want to purchase the book, but there's a website and activities to go with it. So all of these activities are free, and it has pictures of clothes, and then you can say on Monday, Ruby wears green and red clothes, so that students would have to figure out all the clothes that it's possible, but you'd have to have both the green and red clothes on. And then on Tuesday, polka dots or stripes. So there's just ways to do these unplugged activities with your students. I feel like you can actually do more complicated things with your students when you're doing unplugged activities. Venn diagrams, you've got the ands in the middle, the ors on the outside, and then things that don't belong on the outside. Awesome sorting activity. We all tend to use them. Other tweaks, just add variables. You know, if you're flying airplanes, then give them paper clips to add on. Just add those variables. We use variables all the time in programming. Okay, so we're going to skip down to the last couple slides. So here we have I told you that we have a paper and we have a pedagogical framework to help you understand how you could have your students use computational thinking. So the Unplugged usually tends to be more basic, but I feel like in kindergarten it does kind of raise, it's easier to do harder concepts with Unplugged because you're not worried about learning a tool as well. Tinkering, playing around with code, actually making their own programs. If they write a story, that's what they're doing, and then remixing. And these are all aspects of computational thinking. You could go in order, start with the Unplugged and move on up. It's a continuum, but it also could be in different orders. It's just that all of these are necessary in order to fully experience computational thinking. So just before I sign off here, I just want to mention Donna Forster, who's here, and my husband Steve always talks about, and he used to talk about how brilliant she is and all her wonderful ideas, and I finally got the pleasure to meet her a couple of weeks ago, or a couple of months ago actually, and just listening to her talk, it's just everything she says is just so well thought out, and so you might want to follow her on Twitter. It's dforce. Hold on, I'm going to type it in the window because I want to make sure that you know that she there we go. Just check out some of her ideas as well. And Karen's on Twitter as well. I can put that link on the resources. So just she has an article on mathandcode.com, and she's doing some wonderful things with programming with some young students. So I talked about the whole idea of debugging, and we really want our students to value their errors and see them as opportunities for learning, and teachers as well. And you're always making mistakes when you're coding, and you always end up with this in the end. Students are so excited when they solve the problems. If you want to check out more of these, some of these ideas, Dr. Gadanidis' book is available, and I don't get commission for this, but it is available to you at 10% off if you type in that code. So it's Lisa Floyd for 10% off, and this is the book that I use a lot for my students. So thank you so much for joining me. I went to like 8:59. Usually I try and end a couple minutes early, but I'm happy to stay on here if you have any questions. And again, thank you. I really appreciate everyone taking the time to learn.
Okay, that was perfect timing. 9 o'clock. Look at that. Lisa's still here, and you are welcome right now as I'm doing a little wrap-up here to put your comments, questions, or use one of the emoticons and share a little happy face, whatever you'd like. But I am going to advance to a couple of OTF slides. I mentioned at the beginning that when you log out tonight, you will automatically get a link to the feedback survey. But I've just posted 3 links in the chat. The first is to the feedback survey. Please do it. It's really valuable for OTF. It helps to inform them as to what teachers are wanting and needing and craving. And they're starting to do planning for next year, so that would be great. Certificates are available, and there's a resource link there, which is there, but it will be updated. That's one of the things that I will do after we all log out tonight, is to put all of Lisa's links, and there were so many that were just awesome. And Lisa was already saying it's a great resource. You are welcome. You will get a an email with a link to it, but you're welcome to share it with colleagues who weren't able to attend tonight, and then they can go and click on the link and watch the whole webinar with all the resources mentioned and the different videos and so on. So thank you all for attending tonight. And Lisa, that was just a great, great session. You are a rich resource, I'll tell you, and you know, your house looks fun. I'm sure your classroom was the same kind of thing, but such great thinking for students and so important in 21st century. So thank you so much. I think that's probably all I need to say. I'm going to turn off the recording now. I'll thank all of you as well. I know you were enthusiastic. I could feel your enthusiasm coming through in your questions and just in your silence as you were off doing the activities. So I hope it was beneficial. I trust that it was, and we look forward to seeing you back again at another OTF Connect session. So good night, everyone.